Okay, this is AP Stats, assignment 31, chapter 6-3, geometric random variables. It's slightly different probability, and this is one of the example. Roll a pair of dice until you get doubles, okay? So what's the probability you can get double at the first time, right? Or second time, or up to the 4 times, and what's the probability you get the double until you roll 4 times, okay, or 5 times. So that is kind of the questions, the probability we have to run out. Okay. The other thing is the basketball attempt a 3-point shot until you make one. Okay. Keep placing a dollar bet on a number 15 on a roulette until you win. Okay, this is called geometry setting. These are setting. Okay. So a definition of geometric setting is a geometric setting arises when we perform independent trials on the same chance the process and record the number of trials it takes to get one success, until one success, all right? On each trial, the probability P of success must be the same, okay? Then in textbook 405 gives you this type of the question. So your teacher is planning to give you 10 problems for homework. As an alternative, you can agree to play a lucky day game. Here's how it works. A student will be selected at random from your class and asked to pick a day of the week, for instance, Thursday. Then your teacher will use technology to randomly choose a day of the week as a lucky day. If the student picks the correct day, which is, if students pick the Thursday and the computer generates the teacher's pick is matched, okay, and choose the day. And if students picks a correct day, and the class will have only one homework problem. If the student picks the wrong day, your teacher will select another student from the class at random. The chosen student will pick a day of the week, and your teacher will use the technology to choose a lucky day. So in this time, if students pick the Wednesday, it has to be matched to be when the technology has to be matched Wednesday. If the students get it right, the class will have 2 homework problems. Okay. The game continues until students correctly guesses the lucky day. Your teacher will assign a number of homework problems that is equal to the total number to the guesses made by members of your class. Are you ready to play a lucky day game? By the way, I won't give you this type of the gamble thing. And anyway, so just think about it. This next example is based on this type. Okay, just think about what's the probability to choose the right day. So out of 7, only 1 lucky day, right? So in geometric setting, if we define the random variable y to be the number of trials needed to get the first success, then y is called a geometric random variable. The probability distribution of y is a geometric distribution. So this is the definition of geometric random variables and the geometric distribution. The number of trials y that it takes to get success in a geometric setting is a geometric random variable. The probability distribution of y is a geometric distribution with the parameter p, which is the probability of success on any trial. The possible value of y are 1, 2, 3. Okay. So for this the lucky day process, it could be, you know, if the students can hit matched lucky day, if she or he can pick the match day, so it's going to be, if they can nail down for one trial, it's going to be 1, 2, 3, 4, 5, 6, 7, and so on. Okay, there is no end if he or she keeps picking a wrong day, right? Okay. As with binomial random variables, it is important to distinguish situation in which geometric distribution does or does not apply. Okay, so that example we use this. We talk about the from this box, the example. So the random variables of interest in this game is y equal to the number of picks it takes correctly match the lucky day. Each pick is one trial of chance process. Knowing that result of one student's pick tells us nothing about the result of any other pick. On each trial, the probability of a correct pick is 1/7 because it's 7 days in a week, right? So this is geometric setting because y counts the number of trial to get the first success. It is geometric random variable with the parameter p equal 1/7. Okay. So this is if let me move this one so it's easy to see. What is the probability that the first student picks correctly and win the lucky day game? It is written by probability of capital Y equal 1 is 1/7. So because it's 1/7, right? For the first time. All right. That's also the class's chance of getting only one homework problem. Okay. For the class to have 2 homework problems, the first student selected must pick an incorrect day of the week, and the second student must pick the lucky day correctly. The probability that this happens is probability of y equal 2, which is the first time has to be unsuccess, which is 6/7, which has to be failure, and second times choosing the correct answer, which is 1/7. So if it's 1 divided by 7, it's going to be 14%. The second chance will be, it's a kind of multiplication rule, right? So first one is not success, so 6 out of 7 chance, and you have to multiply by success, which is 1. This is second time, so 1. Maybe I should close the bracket. 1 divided by 7. So this is a probability, which is 12.24%. Okay, about third time. So it's failure times failure times success. 1 divided by 7. 10%. right? 10.49%. Okay. Now, so what is the probability to see lucky day within 3 students trial? So you add those 3 numbers, and this is going to be this estimate within nearest hundredths, decimal hundredths. So 0.14 plus 0.12 plus 0.10, which is 36%. So this is how you remember this, okay? So this is the equation. So if you see this is a success, success always at the end. Up to success, you put the failure rate, which is, this is failure to only one time, right? This is failure twice because third time. Therefore, if it's fourth time, if you hit the right, if you a student pick the right day, it's gonna be, you need a fourth time. So you need a 3 failure and 1 success, which is 6/7 times 6/7 times 6/7 times 1/7. So the probability become lower than this number. Okay, now this is how the probability of geometric probability formula works. So 1 minus p, which is failure, and k to the first power, k minus first power, which is if you plug in 1, if you hit the first time, this is going to be 0th power, right? So probability of, wait, k, wait. So if the first part, it's going to be 1. So only that we have to think about is the product of this failure part is going to be 1. So in that case, that you all have to think about the probability of success, right? That's why it's 1/7 at the beginning. Okay, I hope you understand this. Okay, now another lucky day. I will cut the video and I will continue the video for next one. Okay.